Okay, good morning class. You're on to our Mamu experience, and it's me, Mamu Wijadis, considering grade 8 experience with arithmetic. We took off this series by trying to look at whole numbers. That should have been the major topic under consideration, whole numbers. And we've looked at primes, we've looked at factors, we've looked at LCM, we've looked at HCF and the likes. We already started a series called Rules for Divisibility, and today we will continue in that series. A quick reminder here that we have looked at the rules for 2, we have looked at the rules for 3, and we have also looked at the rules for 4 and also for 5. Now, a quick recap. Rules for 2. A number is divisible by 2 if it is even. And how do I know that that number is divisible by 2? The last digit must be even. So if I take a case scenario here, if I have this and I have this, by inspection, if I want to check which number here is divisible by 2, I check the last digits. And because the last digits of this one is even and the last digit of this is odd, I can safely say that this number must be divisible by 2. So how do we test for 3? For 3, I can still use this as my case scenario. Maybe I add a third one. To test for the rules of divisibility for 3, I add up the digits. You must remember the technique and what you ought to do. So I add up the digits, 2 plus 4, that will give me 6. 2 plus 1, that will give me 3. And 3 plus 1, that will give me 4. Now, the rules for 3 says that if I add up the digit and I get 3 or a multiple of 3, the implication there is that that number is divisible by 3. So if I do what is right, I will see that these first two numbers are divisible by 3. Now, how do I test for 4? Rule number 1, the number must be even. And how do I know a number is even? I know a number is even if the last digit is what? Even. The catch here for 4 is this. If I give you a number like this, let's look at those two numbers. This number is divisible by 4 because my concentration will be on the last two digits. I look at the last two digits, and if the last two digits is divisible by 4, it's safe to assume that that number is divisible by 4. Now we look at this. This number is even. It satisfies what we call condition number 1. But this number is not divisible by 4. Why? Because this number 22 is not divisible by 4, which is the minimum requirement for this to happen. So what happens when it comes to 5? 5 is even easier. We look at the last digit. We said that a number is divisible by 5 if that number ends with what? A 0 or a 5. Or put more technically, if the last digit is what? 0 or 5. Now let's have a little recap. Let's go back a little because sometimes students begin to wonder, what are we talking about? Digits, digits, digits. Now, every digit make up a number. So this is a 2-digit number. These are 2-digit numbers. These are 3-digit numbers. Now, in reading the numbers, we start from this position. This is a position called last. And we call it the least significant digit. Map this concept because when we come to significant figures and decimal places, you're going to be applying this idea again. So map it, even if you don't really understand it in full. Keep it somewhere because we are going to be talking about it much later. Alright? That said, we can now come to our work for today. Okay, so we look at something called rules for 6. Now, what is 6? 6 essentially is what? 2 times 3. So it means that to get a rule for 6, I must consider the rule for 2 and the rule for 3. So putting these two ideas together, I can now have a rule for 6. A number is divisible by 3, by 6, sorry about that, if it is even, I deliberately done that, even and it is divisible by 3. If a number is even and is divisible by 3, we say that that number is divisible by 6. So let's take 2 examples now. Let's write some numbers: 3, 2, 4, and 4, 1, 3. And let's take 3, or let's take 5, and 1, 2. And these are the 3 numbers we are going to consider to check if any of these numbers, if any or all of these numbers are divisible by 6. The first thing I want to check is, we said that for a number to be divisible by 6, we expect that number to be what? Even. Is that not? We expect that number to be what? Even. So this does not satisfy that condition. This number is odd, so we can't consider it. We can't do what? Consider it. The next thing we do is to look at these numbers that are even now. We now test whether the number is divisible by what? 3. How do we do that? We add the digits. 3 plus 2 gives me 5. 5 plus 4 gives me what? 9. So this is 9. 5 plus 1 is what? 6. 6 plus 2 is 8. So it's obvious that this number is divisible by 6. Why this number is not divisible by 6? Do you understand that now? So that's how you test and check if a number is divisible by 6. And that settles that. So we come to rule for 8. Okay, so let's look at rules for 8. Rules for 8. How do we handle that? For rules for 8, we must understand that the number must be even. It must be divisible by 4. So look at the conditions as we build them now. It must be even, it must be divisible by 4. And then, in its broader sense, looking at it in a very large number, we expect that the last 3 digits is divisible by what? 8. So we say that a number, put everything together, a number is divisible by 8 if it is even, and not only even, and its last 3 digits is divisible by what? 8. So how do you test this? I'll give you another very easy way to check this. If you divide the last 2 digits, okay, when we get into some serious practical work, you'll get to see how this works. But if the last 3 digits is divisible by 3, we expect that this number must be divisible by, if the last 3 digits rather is divisible by 8, we would expect that this number must, and of essence, be divisible by 8. Now, let's pick examples now. I'm going to pick random examples. And let me shock you. I want to float these digits now. Let's see something. I want to float the digits now. So let's have look at this. We said that the number is divisible by 3 if the last 3 digits is divisible by, a number is divisible by 8 if the last 3 digits is divisible by 8. Now look at these 3 digits here. 240 is divisible by 8, so that ticks. Look at now 024. 024 is the same thing as 24, is that not? So 024 is divisible by what? By 8. So that is. What about 034? Is it divisible by 8? No. Because if I divide this, now look at this. All the numbers past the first condition, they are divisible by what? 2. Now, for me, I won't even stress myself. I'll do a 2 test first. This is 17. So 2 divided 34 is what? 17. So without even stressing myself, I know that this one is not divisible by 8. Please, hear and understand the reason for this technique. Because usually what I do is I could give you, or in an exam setup, you could be given a number and you'll be expected to quickly. I've told students that the greatest challenge we face in an exam setup is not the question. It is your speed. And your speed is tied to how well you have digested the knowledge you've been given. So when a teacher is talking in class, not just maths alone, you must ensure that you try to understand what is the concept. Once you get the concept and you go to practice, it becomes easy to handle this. So that's for 8, and then we'll go ahead to look at that of 9. A number is said to be divisible by 9 if when you add the digits, you get what? 9, or a multiple of 9. So what you have discovered is this. A number is said to be divisible by 9 if when you add up the digits, you get what? 9, or a multiple of what? 9. So what that means in NS is this. Two things you would have observed from this. One, there are 2 numbers consideration, or 2 considerations that involve you adding digits. The first one is what? 9. The first one is what? 3, and the other one is what? 9. Let that sink. Let that sink. So you can test if a number is divisible by 3. If you add up the digits, you're getting 3, or a multiple of 3. And here we're using that same technique here. We add up the digits and see if we're going to get 9 or a multiple of 9. So let's try that. A number is divisible by 9 if when its digits is added, it gives 9 or a multiple of 9. It gives 9 or a multiple of 9. Maybe before the end of the session, I'll also add up to this idea. There are other things you can also do. It's what I call first level addition, second level addition. I'll explain those concepts later, but for now, let's keep it very simple. Now, I have a number like this. I have another one like this. I have yet another one like this. So the rule says I must add it up to test. This will give me 9. This will give me 9. 3 plus 2 is 5 plus 4, 9. 4 plus 1 is 5 plus 4. That will give me 9. 9 plus 2 is what? 11. 11 plus 5 is what? 16. 16 is not a multiple of 9. But I can also give you what I call second level addition. You can carry out another level of addition, you get 7. So I can rephrase this theorem to say that a number is divisible by 9 if when its digit is added, it gives 9 and 9 irrespective of the level of addition. That's an advanced definition, and I wouldn't want you to bother about that. As we begin to solve more problems, you get to understand this thing very well. So this is what you're expected to do. And when you do that, this is what you're expected to obtain. So the importance of this is for you to be able to look at numbers and quickly decide what can be divided. If a number is even, try 2, try 4, try 8. If a number is odd, add it up and see if you can divide by 3. Or it's a multiple of 3 or 9. Alright, let's come to 10. Rule for 10 is very simple. A number is divisible by 10 if its last digit is 0. So that's that for the rules of divisibility. So any number whose last digit is 0, straight away, 40, 250. No, yes, yes. So it's quite straightforward, and we want us to waste our time there. Any number that ends with 0 or whose last digit is 0 is divisible by 0. So that clears out our discussion this morning on rules of divisibility. We'll now take on something rather different from this.